Good morning, grade 8. Today we are going to start lesson 3, thermal property. We mentioned in lesson 2 how heat transferred from warmer area to cooler area by three ways: conduction, convection and radiation. Yes, so I need material to transfer the thermal energy or the heat. Yes, to transfer the heat. Some materials conduct the heat well and others do not. So we have different materials, all of you know. We have metals, we have non-metals, we have plastic, we have wood, we have iron, we have copper, we have different materials. So some materials that conduct the heat well called conductors. Yes, so conductors are materials that conduct the heat well. Like metals. When I hear about conductors, I mean metals directly. So metals are good conductors. Why? Why metals are good conductors? Because of the particles. The particles of matter arrange itself in a definite way. Yes, in a regular shape or regular structure. This is make solid shape for metals. All metals are solid except mercury. Mercury is a metal also, but in a liquid state. Mercury is a liquid metal. So metals are good conductors because of the particles they contain. How those particles are arranged allow heat pass through it. Okay? So the particles of metals arrange itself like this, in a definite pattern or a lattice shape. So heat transfer easily through metals or through conductors. Heat transfers out of conductors easily. Also, heat can leave the conductors easily. So heat can enter and pass through conductor easily and also leave it easily. Okay? Number 2, other types of materials that do not conduct heat called insulators. Insulators mean bad conductors. Insulators mean bad conductors. So insulators are materials that do not conduct heat well. Are materials that do not conduct heat well. Conductor and insulators, we can make comparison between them. Conductors transfer thermal heat well. Insulators do not transfer thermal heat well or energy well. Conductors, materials like metals such as silver, gold, stainless steel, copper, aluminium, all these are good conductors for heat. Okay? What about insulators? Non-metals, opposite of metal. Like wood, like wool, like straw, like clothes, cotton, like blanket, like air. Don't forget air. Air is a bad conductor. Air is insulator. And paper, and the glass, and plastic, and rubber, silicone, all these are insulators, or good examples for bad conductors. Insulators mean bad conductors, and the conductors mean bad insulator. Okay, conductor means bad insulator. And the insulator means bad conductor. Don't forget. Good conductor, such as tile, floor, feels cool. Why? Because it allows heat transfer through it. Yes? Feels cool to the touch because it's easily transfer heat away from your skin. Exactly like when you hold an ice cube or touch any cold surface. I feel cold. Why? Because my body heat transfer through the air, or transfer to the ice cube, because the heat transfer from the warm to the cold. So the temperature transfer from my hand to the ice cube. Exactly. Tile floor. Tile floor, good conductor. The heat transfer from my body to it. So I feel coldness from the tile. What about insulators? Slow transfer of heat. Slow. Slow. Very slow. Okay? Very slow. Other point in the thermal properties, thermal expansion. Expansion means increase in volume. Expansion, expand. What happened during expansion? The particles gain energy. Yes, so the particles expand. So expanding of matter, this is what I mean by thermal expansion. What happened when the particle expand? The volume increase. Yes, when the particles expand, the volume increase. The expanding due to heat, energy acquired. Yes, so the expanding of matter when it's heated. When it's heated, yes, as the thermal energy of matter increases, its particle usually spread out. Spread out means expand, causing substance to expand or volume increase. Opposite of expansion, contraction. Opposite of expansion, contraction. Contraction means volume decrease. Yes, thermal or contraction as general means the volume decrease or contract, shrink. Okay? Look at examples in our daily life. To loosen a jar lid. Jar lid made of metal. So metal good conductor. So it expands by heating. Yes? Expand and contract. So to loosen a jar lid, you can hold it under a stream of hot water. Yes? Why? Hot water make the particles of metal or lead metal what expand. So the volume increase, so I can open it easily. I can loosen it easily. Yes? What about road joint and train track? Look at road joint. Yes, road joint. Yes, and this is power lines. Power lines also we leave a lot of space. Yes, we leave a lot of space between the train track, and we leave space between road joint. Why? Because metal expand by heating. Expand during summer. Yes, in hot weather the metal expand because metal is a conductor. Yes, metal conductors, wood conductors. Okay, so when the metal expand, so it find space to expand through it. Yes, if no space, what happened to the track or line that made of iron? Will crack. Yes, will crack. Also, the wire is stretched during summer because it expands. If no space, it will cut off. Yes, look at road joint. Yes, this is made of metal. If no space, how the roads, how the trucks move on the road. Yes. So when a matter, the opposite, when matter is cooled, the opposite happens. Thermal energy is released. Particles slow down and move closer. It decreases in volume. This is power line. Yes, example, power line. Yes, when matter is cooled, the opposite happens. Thermal energy is released. particles slow down and move closer, it decreases in volume. It decreases in volume. Power lines or power cable, we have to leave space and to allow the line stretched, yes, and contracted, and also joint. And also you have to know different material expand and contract at different rates, not at equal rate, because we have different material. We have copper, we have iron, we have stainless steel, we have a lot of alloys, more than two metal mixed together to make alloy. They expand and contract at a different rate from the other metals. Okay, this is the lesson of thermal products, conductors, insulators, thermal expansion. Thank you all of you.